Chalo, okay Avinash, so today we are going to start the new chapter, that is metals and non-metals, okay?
Okay, sir.
Huh. So metals and non-metals, do you know what are the metals?
Yes, sir.
What are the metals?
The object is made up of a metal.
Made up of?
I don't know.
Okay, what are the non-metals?
Which is not made up of metals.
Okay, so can you give an example for some metals and non-metals?
Non-metal means a plastic bottle, a bag,
Okay,
a sheet, pencil,
right, metals?
steel bowl,
Hmm?
bowl,
Oh,
bowl,
okay,
like
right, okay. Now we discuss, okay, one by one, very detailedly. So listen carefully, very important chapter, even it is there for your, you are in 8th class, no? So in the 8th class also there is this metal and non-metals, okay? And we discuss here some little advance, okay? Then actual what we have, right? Okay. So this is our third chapter, metals and non-metals. So see here, so we take the third chapter, that is metals and non-metals, okay? So here you can see metals means, like, can you see on the screen? So this is a brass, okay? Brass means, you know the brass? No. You know Telugu, ittadi, you know ittadi?
yes, sir, that
Ah, so that is. And aluminum, do you know aluminum?
yes, sir.
Yes. And these are iron, copper, do you know copper?
Yes, sir.
And steel.
Yes, sir.
So these all are comes under the metals. Okay. Now if you come to the what are the non-metals here? Example, this is sulfur. What is this?
Sulfur.
Sulfur. Sulfur is a non-metal. Okay. And this is carbon. What it is?
Coal.
Carbon, coal, yeah. So these are the non-metals. They are not metals. Okay. So now let us see what are the one by one individually what are metals and non-metals. Okay. So here you see generally elements are classified into metals and non-metals based on their properties. So here you see Avinash, do you know about the periodic table? Yes? You don't know, I think, no? So in the periodic table, 1 minute, can you see all the completely elements word, can you see here? Full word?
Yes, sir.
Element E, can you see?
Yeah.
1 minute, I think you have to adjust just a minute. Right. So here there is one table will be there which is, oh. So there is one periodic table you learn in the higher classes, periodic table. That periodic table consists of total 118 elements. Okay, already we discussed about the elements and molecules and compounds, no?
Yes, sir.
So total we have 118 elements are there. Okay, so total number of elements, okay, total number of elements are 118 elements are there, and these elements are classified into two types. Okay, so they are called metals and non-metals. Actually one more type is also there called metalloids. Okay, so three types. Okay, So the generally these 118 elements are classified into 3 types called metals, metalloids and non-metals. Okay, but here in this chapter we are going to discuss about only 2 elements. They are called metals and non-metals. Is this clear to you?
Yes, sir.
Right. Now, so now you see here, metals are the elements which forms positive ions, very important, by losing electrons. Thus, metals are known as electropositive elements. So here already we discussed about, I think, the ions means you know that atom consists of electrons, protons and neutrons. Yes or no? So in these electrons, protons and neutrons are present in the atoms. So these in these metals, generally these metals lose the electrons. They lose the electrons. So electrons are negatively charged particles. Electrons are what? Negatively charged particles. So when they lose these negatively charged particles, then they become positively charged. Then they become what?
Positive.
So they have become positively charged. So these elements are called electropositive elements because they are attaining the positive charge. By losing electrons, they are attaining the positive charge. Hence, they are called electropositive elements. So generally, metals are electropositive in nature. Generally, metals are how they are? Electropositive in nature. So you can see on the screen now, metals are the elements which forms positive ions by losing electrons. Thus, metals are known as electropositive elements. Is this clear to you?
Yes, sir.
Right. Then go to the next topic, next point. Now example for some metals. So examples for some metals here: iron, aluminium, silver, copper, gold, platinum, lead, potassium, sodium, calcium, magnesium, etc. So all these are examples for metals. Okay, you know that iron is a metal, yes or no?
Yes, sir.
So iron is a metal, aluminum is a metal, silver is a metal, gold is a metal, copper is a metal, platinum, lead, potassium, magnesium, sodium, calcium, all these are examples for the metals. Okay, so these all are the metals. Okay.
Okay.
Now then come to the next one. Now let us see the non-metals. So metals and non-metals. Non-metals are exactly opposite to the metals. Yes or no? Non-metals are exactly opposite. So metals are what? Electropositive ions by losing electrons. So they are losing electrons and forming the positively charged ions. And now non-metals are what? Opposite. So opposite means what? Atoms, the metals are losing the electrons. So they will gain the electrons. Yes or no?
Gain the electrons.
So non-metals are the elements which form negative ions by gaining electrons. So see here, negative ions, non-metals form negative ions by gaining electrons. Thus, non-metals are known as electronegative elements. So thus, okay, non-metals are known as what? Electronegative elements. Okay, so non-metals are elements which forms negative, okay, ions by gaining, okay, electrons. Thus, non-metals are known as electronegative elements. So they are exactly opposite. See, metals are called what? Electropositive elements, and this okay, electropositive elements, and these non-metals are known as what? Electronegative elements. Okay. Right. Now let us see some examples. Example for the non-metals here: carbon. In the figure before slide I have shown the figure, no? Okay, carbon. Sulfur, I have shown the sulfur also. Okay, sulfur. Phosphorus. Okay, phosphorus. Do you know what is phosphorus? Where do you use the phosphorus?
I don't know.
Huh?
No, sir, I don't.
Okay, matchstick is there, no matchstick?
Yes, sir.
There we use the phosphorus, that is made up of phosphorus. Okay, So when light it, then what happens? It will catch the fire. Okay. So phosphorus is reactive element. It catches the fire even at room temperature also. Just temperature if increases, it catches the fire. So phosphorus is used in making the matchsticks. Okay. So examples for the non-metals are what? Carbon, sulfur and phosphorus. Is this clear? Chalo, note down this on all points one by one slowly. I'll give the 2 minutes time to you. Very, very important points all this. Completed. Okay. So, is this clear in this slide? Any doubt?
No, sir.
Right. Now, let's go to the next slide. So, here let us see what are the physical properties of, okay, metals. So, here one very, very important. See, this is for your class also important. 8th class, this topic is there. The first property is called malleability. What it is called? Malleability. Malleability means what? Elements on beating, okay, so they converted into thin sheets. They can be made into what? Thin sheets. So this is called malleability. Okay. What happened here? So that is called malleability. So malleability means what here? The property of a substance due to which it can be beaten into thin sheets. Okay. For example, if you have one metal piece, you think, if you have one metal piece, take that metal piece and continuously hit with the hammer. Okay. Do you know the hammer?
Yes, sir.
Continuously hit with the hammer, then what happens? It becomes like a thin sheet. It becomes like a thin sheet. It will not break. For example, this pen is there. If you put this pen and hit with the hammer, so what happens? It breaks into pieces. Okay, but metal, it will not break. So if you continuously beat, so what happens? It can be made into the thin sheets, like you know the plates. Okay, so this property of metals is called malleability. Very important property. Remember this word, malleability. Property of a substance due to which it can be beaten into thin sheets. So metals are malleable while non-metals are not. Okay, non-metal, for example, see this pen is made up of non-metals. If you hit with the hammer, so what happens? It completely breaks and make into the powder, but it cannot made into a thin sheet. But similarly, you can take the metal and hit, so it can made into a thin sheet. Is this clear? This property of converting means you are making the metals into thin sheets is called malleability. Note down this one, malleability. Property of a substance due to which it can be beaten into thin sheets. It can be beaten into thin sheets. Is called malleability. And metals are malleable while non-metals are not. Right? Chalo. Going to the next property. Ductility. Ductility means what? The property of the metals which can be drawn into the thin wires. Which can be drawn into the thin wires. So you can see the copper wires. You know copper wire? So copper wire. So wire can be drawn into thin wire. That is made up of copper metal. So copper metal, what we are doing? We are drawing into the thin wires. Okay. So like gold chains are there. Generally, okay, girls, okay, women wear the gold chains. So these gold chains are made up of thin gold wires. Okay. So this is called, the property is called ductility. Ductility means what? The property of metals that can be drawn into the thin wires. Okay, and generally metals are ductile while non-metals are not. The same thing you can see on the board. Property of a substance by which it can be drawn into the thin wires. Okay, metals are ductile while non-metals are not. This is called ductility. Remember, very important. Okay, right. Right. Now let's come to what is the third property. The third property is what? Conduction of heat. So generally metals are the good conductor of heat. So means what? Heat can easily flow through the conductors. Yes or no? For example, if you take the hot milk in the cup, okay, and place one metal spoon in that, and after some time you try to hold the spoon, so it becomes very hot. Yes or no? Generally, when your mom cook the rice or curry, so she'll keep in the curry that vessel where she is cooking in that she keep the spoon, and she just forget, and she may ask you like, okay, once you stir it, then if you go and touch it will be very hot. Yes or no? So because metals are the good conductors, heat easily can flow through the metals. So generally you take the the cookers, okay. In the cookers are made up of metals, but you can handles are there. So do you know the handles, how to hold the cookers?
Yes,
Is that handle made up of metal? No. So they are not made up of metal, they are non-metals. Okay, if you hold them, we cannot get them hot. Okay, so it will not burn. Okay, so they'll be cool easily. We can take the So this ability of allowing to flow the heat through them is called as a conductivity. So metals are good conductors. Is this clear to you? So see on the screen now, conductors of heat. Metals are good conductors of heat. Metals are good conductors of heat. And silver and copper are the best conductors. Among the conductors also, which are the best conductors? Very important point. Silver and copper are the best conductors, while lead and mercury are somewhat poor conductors. Lead and mercury also, they are metals only, but comparatively they are less conductors. Okay. And non-metals are bad conductors of heat. Non-metals are what? So they do not allow the heat. Okay. So for example, you see here one diagram is there. I'll explain you with the diagram. Okay. Can you see the diagram here? So in this diagram you see, here we are taking one metal rod. Okay. This we are taking one metal rod. Okay. To this metal rod we are fixing some pin. Okay. One iron pin we are fixing with the help of wax. You know the wax, candle wax? Yes. So by putting the candle wax, so we are fixing here. So now nail is fixed to this place. Okay, iron rod. Now what I am doing, I am taking the burner and I am heating the metal rod here at this position. At this position I am heating. Okay. Now wait for some time. Now what you will observe after some time? Then so what happens? The heat, this copper wire becomes hot, so the heat will flow like this and it will reach to this end. So here what's happening? The wax is there, wax will melt and iron nail will fall. Yes or no? Yes. So iron nail, where is iron nail? Here is iron nail. Okay, so here is the iron nail. Okay, so here is the iron nail. Iron nail is here. Okay, but we are heating here. So from here to here the heat is flowing, and after some time this iron nail, the candle wax is melting and the iron nail is falling down. So meaning is what? Heat is flowing through that rod. Is this clear to you? This property is called a good conductor. So the metal allow the heat to flow through it. Metals allow the heat to flow through them. So this property is called a conductor. Is this clear to you? So now right here, conductors of heat. So metals are the good conductors of heat. And this also you can write silver and copper Okay, silver and copper are the best conductors, while lead and mercury are the poor conductors. Completed. So first one is malleability. Malleability means what? Which can be made into the thin sheets. Okay. Ductility, which can be drawn into the thin wires, and conductors of heat, which allow to flow the heat through them. Now next property you see here. Metals also good conductors of electricity. Metals are what? Good conductors of electricity. So here you can see our so somewhere the plug will be there and somewhere the bulb will be there. Okay, and these both are connected with which wire? Metallic wire. Yes or no? And above that, of course, there is a plastic wire will be there. So because metals are the good conductors of electricity, so electricity will flow. If you touch that only wire, then we can get the shock. Yes or no? So that's what they coated with, they cover that with the plastic. Okay. So metal wires, they are the good conductors. Metals are the good conductors of electricity. So see here, metals are the good conductors of electricity, while non-metals are bad conductors of electricity. Okay, but of course there is some exceptions are there, like graphite. There is one material is there which is called as a graphite. It is not a metal. It is not a metal, but still it can conduct electricity. Still it can conduct electricity. This is exceptional case. Okay, so in the important in your examinations, means in the IIT exam, somewhere they may ask you, okay, give an example for the non-metal which conduct electricity. Non-metal but which conduct electricity. Okay, so you can write graphite. What is that? Graphite. Graphite is an example for the non-metal, but it's a good conductor of electricity. Okay, so come on, go through this one. Yes, see here we have one diagram also. Can you see the diagram here? So in this diagram, can you see the total diagram? No, something is missing. Okay, so here you can see here, here there is a battery. This is called battery, and actually here one bulb is there here. Here there is one bulb. Okay, here you can see one bulb is there, and now we kept the gap here. Okay, the positive terminal is connected to one end of the bulb, and a negative terminal we are bringing like this, and we are keeping one plastic clip. Another plastic clip is also there. Plastic clip is, we to hang the clothes we use. Okay, this clip, and again we are taking one wire and we are connecting to this bulb. Does the bulb glow now? No. Here my break is there. Okay, now what we do, we combine this both, like the two clips we make to attach. After attaching, does the bulb glow now? So the bulb will not glow. Yes or no? The bulb will not glow. But now instead of this plastic clips, if we use some metal here, we join this two gap, the gap with the metals. Okay, does the bulb glow now?
Yes, sir.
Yes. So now the bulb will glow. Here the bulb will glow. Yes or no? So this. Okay. So meaning is what? This metals are the good conductor. So metals allowed to flow the electric current through them. Okay. So hence they are called as a good conductors. Is this clear?
Yes, sir.
Chalo. Note down this one also. Done?
Yes, sir.
Chalo. Go to the next property now. Next property is called a luster. Lustrous property. Luster means what? Generally when you take the metal, so when you freshly cut the metal, or when you take the metal, then you can see if you go to the gold shop, okay, then how will the metals be? The metals will be shiny. Yes or no?
Yes, sir.
A silver, that will be shiny. Even iron also, if you cut freshly cut one, then you can see that will be shiny. Aluminum, you can see that is also shiny. In our house you can see the stainless steel vessels, that also shiny. Yes or no? So generally metal surfaces are very shiny. This property is called luster. Okay, so generally metals are lustrous. Lustrous means what? The property of shiny. Okay, so here you can see appearance of surface. Metals in their pure state have a shiny surface. What they have?
Shiny, sir.
shiny surface. This property is called metallic luster. So till here only, right? No need to write all. So generally metals appear shiny. The surface of the metals look like very shiny. So this property is called as a luster. So generally metals are lustrous. Only simply you can write. I will dictate, you write. Its point is very big. So I can write. Okay. Luster, L-U-S-T-R-E, right? I just cited, okay, right, luster, and then I will say dictate like this. Generally, the metal surfaces are shiny. Generally, the metal surfaces are shiny. This property is called metallic luster. This property is called metallic luster. Is this clear? This property is called metallic luster. Metallic, here metallic luster. Okay? Metals, their surface is generally shiny. Okay? This property is called metallic luster. Okay, one more point. Yeah, this is also important point. Generally, you see the metals are hard. Yes or no? If I give this pen, you break means easily you can break. You can hold like this. If you apply little bit force, then it will break. But I'll give one same metal rod like this, like iron rod or copper rod, something the same thickness. Can you able to break it? No. So because metals are very hard. Okay. So the next property is the hardness. Metals are generally hard. Metals are generally hard. Okay, very hard. So it will be difficult to break them. So write this property. Metals are generally hard. Okay. But there are some metals are there like sodium and potassium. They are very soft and they can be easily cut with the knife. Okay. There are some metals are there which are soft. Okay, just like sodium and potassium, we can give an example. So in the example, this question also will ask, generally metals are hard, but which of the following metals are soft? So here you can give an example like sodium and potassium. These are metals, but these are soft. Okay, right. Next, density. You know the density? Density means mass per volume is called as a density. Okay. So for example, you take one sponge you take. Otherwise, not only sponge you can take. For example, okay, I am taking this book. Okay, I am taking one book. So how much is the book length, breadth, height means this thickness. Okay, this type of, okay, this I will take. So in the same way, the same size of one metal plate I will take. Metal plate. Does both will have the same weight? No. Which one will have more weight? Metal will have the more weight. So that is due to its density. This property is called a density. So metals have high density. Metals are generally high denser. Few metals are there, like I said, like sodium or potassium. Okay, you write this one. So with this we stop today's class. In the next class we continue this chapter. Okay? Yeah, you can write this one, and after writing you can leave.